This is Deep Thoughts with Deegan, and today I'm going to be talking about ways you can remember some of the difficult to remember or painfully slow calculus concepts when talking about derivatives. So I'm talking about product rule, quotient rule, chain rule, and also how to remember the trig derivatives as well as their inverses. So let's get started. So first I'm going to talk about product rule right here. I have the full thing written out, and you can see there's a lot going on here, it looks like, but I'm going to show you how to do it a lot faster than this. I think what a lot of people do is they just take f of x, plug it in, g of x, plug it in, f prime, g prime, and so on. I don't think about plugging things in. What I do is I just take all of them and I throw them together. And the way I do that, a lot faster than just calculating each one and doing all that. You do have to calculate each one, but it's a little bit different. Where we have our f of x on the top left, I create a little box. I do the same thing for quotient and chain rule also. Down here, there is g of x, right? And on the other side, I'm going to have f prime of x and g prime of x. And then from here, for product rule, this base right here is what I use for all of the product, quotient, chain rules. And then what I do with this box is a little bit different for each one. For product rule, I start up here, I circle these two, now I have f of x, g prime of x, because this product rule, it's going to add, right? Then I start up here, circle these two, f prime of x, g of x. If you look at it, it's the same thing. The terms are flipped, but it's the exact same thing. So now I'm going to show you just how quick this actually is. All right, so I got a pretty simple one here. We're looking for the derivative of x squared times ln of x. To do that, I'm just going to draw my little box. X squared ln of x. Then right here, the derivative of x squared is power rule 2x. Derivative of the natural log of x, 1 over x. Do the same thing I did before. I'm going to group these together. You can write the whole thing out, but whenever I can simplify it easier, I will. So right here, we can see x squared divided by x, because x squared is going to be this numerator because we're multiplying. So actually, we're just going to end up with x for the first term. We're going to add, get these two together, 2x times ln of x. Pretty easy. Now I'm going to show you another example of one that you can actually use another shortcut for on top of it. Now right here, I have the derivative of e to the x times sine of x. Now e to the x is special because no matter how many derivatives or integrals you take, it's always going to be itself. So what we can do here is firstly, I'm just going to write out the full thing. I'm going to do that over here where we got e to the x, because the derivative of e to the x is e to the x, sine x, the derivative of sine x is cosine x. Bring it all together, we get e to the x times cosine x. There we go. Because remember, I kind of take that. It's a little messy, but it's the same thing. Plus these two, e to the x sine x. Now, if you notice, you can actually take a factor out of this, which will be e to the x. They both have a common factor of e to the x. So now it's just cosine x plus sine x. Right? That's pretty simple. Now, if you look here, you can take that e to the x out because it's both here. Both of them are going to have a factor e to the x. So no matter what these are, let's just say these are both e to the x, and this is some f of x, and this is f prime of x. Now, these are interchangeable, so you can do it either way. But no matter how you do this, look, we're going to have e to the x times f of x, e to the x times f prime of x. Either way works. So if I start here, both of them are going to have e to the x, so I put them on the outside. Now this first one is going to have f prime of x, right? And this one right here is going to have f of x. That's a bad f again. And based on that, we can see every single time we have e to the x times some other differentiable function, it's going to end up looking like this. So that's pretty cool. But no matter what, it's always going to work as long as this other function is differentiable. Now, quotient rule here, by far my least favorite. I mean, just look at it. It just looks terrible. You got this entire thing. It's a mess. It's by far the hardest of these simple-ish rules to remember. So I also have a trick for this one. Same thing with the box. We got f of x, f prime of x, g of x, and g prime of x. Now this one will be a little bit different. Instead of starting here like we did with the product rule, we're going to start up here. And we're going to take this whole thing, right? I'm going to write it down here. We get f prime of x, g of x. That's this right here. Now, because it's quotient rule, there's going to be a subtraction here. Now we're going to take this, f of x, and then g prime of x. And then, just to remind myself, I circle this one again, because sometimes I'll forget. So if I have it in my muscle memory that I have to circle that one again, I'll come back to it. And then on the bottom, that's how I remember. I have to add this g of x part, and it's just g of x squared. If it helps, you can circle it twice, so you know it's, g of x times g of x. But this is how I do this one. Takes a little bit longer than the product rule, but it's a lot better than trying to remember this entire thing. So now I'm going to go to an example of this. Now for this one, we have the derivative of tangent of x over x. Now if you remember, the derivative of tangent of x, which I'll write right here, is secant squared of x, right? Some of these trig derivatives are kind of hard to remember, so I'll just have this here for now. But from there, we just do the same thing that I was talking about before. Our f is tangent of x, and I put it on the top for this one because I don't want to put that in the g squared because I don't feel like it right now. Derivative of that is secant squared x, right? And bottom, our g of x function is x, derivative of that is 1. So now I'm going to put it all together, right? We get, starting here, we get x secant squared x minus this right here, which is just tan x, because 1 times tangent of x is tangent of x. Then we got this, circle that twice, just to remember it. That's just going to be x, that's our function, squared. See, a lot easier than going through that whole thing and remembering where everything goes. Using these kinds of things, you don't have to remember the entire formula. You can just kind of go through it slowly. So now I'm going to do chain rule, which is probably the easiest one, but also it's the most different. So next I'm doing the chain rule here. I have the formula right here, but this one's a little easy to remember, I will say. But I also still have a shortcut for this one that makes it faster. It's not really a shortcut, it does the same thing, but we're going to start with the same spot as the quotient rule, where we started right here, right at the top of that. I'm going to circle these two. Right, we're going to start with doing something with these two functions. Now, we're not multiplying it like we were with the other ones. This is just going to be that first composition. And the reason I do all these circles and stuff is it lets me know which functions am I working with, so I don't have this jumble going on. So then I know this is f prime of right here, g of x. And if it helps, you can actually just like draw, and sometimes I'll draw an arrow for this one instead, where I'll have like, get rid of that a little bit. It's still there a little bit, but if we have f of x to g of x, f prime of g of x here with that, and then I'll go circle here for multiplication times g of x, g prime of x. You see, f prime of x, start at the top right, go down to g of x. This is our composition. Now we're going to take it over here, circle with g prime of x. That goes on there. So I'm going to do an example of this one. So for this example, I'm using inverse trig. So we're looking at the derivative of the arctangent of 2x. Now just for a little bit of a reminder, because the inverse trig are the hardest to remember by far. The derivative of arctan is equal to 1 over 1 plus x squared. This is probably the easiest of them to remember. That's why I chose this one for this example. But now I'm just going to write these over here. Our first one is arctan x. And then the derivative of that is 1 plus x squared. Now we got 2x. The derivative of that is 2. Put it all together. Composition for the arrow. We get 1 over 1 plus. We got inside of the x here now is 2x. And we're going to multiply that by 2. So if you really wanted to simplify that, that would go down to 2 over 1 plus 4x squared. And there we go. See, it's a lot easier if you do it this way, and you can do that if it helps. So now I'm gonna go do something different. Now we're gonna talk about how do you remember all the trig and inverse trig, because there's so many, and sometimes it's really easy to forget. And you don't really want to go through the entire steps of like sine divided by cosine or 1 over cosine for secant of x. Right here I have all of the basic trig functions from sine of x all the way to cosecant of x. Now I have these organized in a way. This little grid is how I remember these because there's some patterns in here. Now the easiest one right here, let me get the correct marker. The derivative of sine of x is just cosine of x. Also pretty easy right here, the derivative of cosine of x is negative sine of x. Now right here, you'll notice that this is positive and this is negative. That'll hold true for all of these. So now for tangent of x, the derivative of the tangent of x is secant squared of x, right? You just kind of have to remember that one. But from there, the derivative of the cotangent of x is negative, like we had here, cosecant of x, cosecant squared of x. So also notice it flips. So we got from cosine, this is 1 over cosine. From sine, it's 1 over sine. So that's one way to remember it. You go from here, you flip to the other side from cosine right here to sine. So we get from secant, which is 1 over cosine, cosecant, 1 over sine. Make it negative. Now for secant of x, that's going to be secant of x, tangent of x, right? That one you just kind of have to remember. Now here, it's going to be a pretty similar situation where you just flip the one you're using. We go negative. It's going to be cosecant x, cotangent of x, right? You're just flipping the one you're using. That's why I have them in these groups. So when you're using this one, you flip to this one. When you're using this one, you flip to that one, and so on. That works for all of these. That's how I remember these, at least. So for this last set, we have the inverse trig functions. So what we're going to do here is we're going to always, for all of these, we're going to start with a 1 in the numerator over something. Now for this one, it's going to be the square root. For the cosine, it's the square root of something. And in this case, it's x squared plus 1. Now over here, the only difference is we make it negative. Negative 1 over the square root of x squared plus 1. Very similar to the regular trig functions. The only difference here, though, is this is positive, this is negative. Otherwise, the exact same across. So now the derivative of the arctangent of x is just going to be 1 over x squared plus 1. Go over here, make it negative. Negative 1 over x squared plus 1. Down here, the secant and cosecant are the most difficult ones to remember, alongside having the weirdest names. But here, it's going to be 1 on the top, like always, over. Let's try that one more time. Over the absolute value of x. This one has the absolute value. Square root of 1 minus x squared. And the way I remember this is because it's the opposite of that, right? It flips them, because it's really easy to flip the signs and the positions, right? Now over here, again, make it negative. Negative 1 over absolute value of x, square root of 1 minus x squared. This is all of them. All you have to do is memorize these three. The arcsine has the square root. The arctangent has nothing, just a square. The arccosecant has the absolute value in there along with the square root. Now, if you remember these three, just make these negative for their reciprocals. Well, that's the end of this video. Hopefully this was helpful. If it was, leave a like, comment, and, well, I'll see you next time. This was Deep Thoughts with Deegan.